We're going to look at the motor protection devices. So motor can be quite a big investment, and got to protect the motor. So we traditionally protect our circuits with MCBs, RCDs, HRC fuses, etc. But there are specialized protection devices for motors as well. And sometimes we can get one device that will encompass everything, and we set it all up, and it will sit there and look after the motor. Sometimes with motor protection, they try and ensure the motor protection doesn't pop out too often, because sometimes if it's a big production line, just a matter of half an hour downtime can cost them hundreds of thousands of dollars. So they've got to get their motors protected really well and ensure they're not popping out too often, but also ensure that motor doesn't break down. I think the data is the actual cost of a motor is probably about 3 to 5%. That's the actual cost of the motor compared to its lifelong cost. Okay, so when they buy the motor, that's about 5% of the lifelong cost, like all the energy cost that gets put into that motor and all the maintenance costs and upkeep adds up for the rest of the cost. Anyway, let's move on with this. Okay, so what are we going to protect our motors against? We're going to protect them against overload. So when we've been working on those control boards in Maraho, and we've been working on our virtual control boards, we've had a motor overload sitting underneath our main contactor. Okay, so the overload will protect overcurrent. So if our motor starts to draw too much current, it will trip the motor overload, and then it has to be manually reset. So the problem with the motor, though, is sometimes it can be 6 to 7 times when we start the motor up, 6 to 7 times the running current. So our overloads are designed to accept that. Single phasing. If we have a phase dropout, our motor will be running, if it's a 3-phase motor, our motor will be running on 2-phase. The motor will run uneven. It'll have a vibration to it. It will sound different, but more importantly, the other 2 phases will load up. Okay, so this could cause the motor to burn out, just like the overload could cause the windings to burn out. Over voltage. If we get too much voltage to our motor, if there's a spike in the voltage or the network voltage rises up, that can cause our insulations to break down. Our insulations will be rated at a higher voltage than the running voltage, but then if our voltage comes up, our peak voltages will increase, and that will cause them to break down. Also, the over voltage could cause overcurrent, which could cause temperature rises. Under voltage. If we don't have enough voltage there, the power output of the motor will drop away, and it may cause the motor to mechanically load up, and this could cause over temperatures as well. Okay, so 2 things we want to keep an eye on: over voltage, under voltage. Okay, and finally, over temperature. We want to keep our motor cool, or not cool, but we don't want it to burn out. Okay, so we can put devices in to monitor the temperature of the motor, and we've got to protect the motor against the environment. So the motors can be put in lots of different places, so we've got to take that account of the environment, and it might be dusty, might be wet, might be humid, might be like a petrol station where it's very hazardous, these gases, so we can't have sparking and things like that. Okay, let's go down. We're going to look at overload relays. This first one up here, overload. And here's a picture of one very similar to what was sitting on our main contactors. So this one here plugs straight into the bottom of your main contactor, and then you put your lines straight out the bottom. And it has some dry contacts here, okay? Normally open and normally closed. We were wiring our one up here, our control circuit, in series with our stop buttons, so that then when this tripped, it stopped the whole circuit, and then we have to reset it manually. Selection here to set up our running current, and depending on the model, it may have many other features built into it. Generally, they have more than just overload built into them. A lot of the time, they'll have single under voltage, over voltage, single phasing, all built into the one unit. Okay, so in here, there's a few ways of doing it. So they put a small resistor in, so as the current goes through, more current goes through the resistive element, produces heat, and they have a bimetal strip sitting on top of it. So it will heat up, the bimetal strip will open. And this little screw here sets the adjustment on the bimetal strip. We set it to the motor running current, and the starting current is allowed for with a time delay in it. Fits straight into the main contactor, this one here, so we can just, that spacing's for us to just put it straight in the 3 screws, and comes with some reset and test buttons. Okay, this one must be manually reset, so if the motor does overload, the motor will stop, someone has to come and manually reset it. So that motor won't start automatically, which is a good thing. These contacts can also, okay, they could be for put in series with a control circuit, which is what we do, or it could go to another control system, to a PLC or monitoring system. It could even send out messages on the network to maintenance people. Okay, single phasing. Single phasing, we drop a phase or 2 phases, uneven running, okay? Overload of the other phase, over current and or over temperature. So a 3-phase motor, if it drops a phase, we need to shut that down because it will overheat and damage the motor eventually. So we can have separate relay units which will monitor the single phase, or it's encompassed within overload relays. Generally, you'll get a unit like this, and if you buy the right one, it'll have single phasing built into it. So it's a nice, simple solution. Okay, so single phasing, how can it happen? It can actually happen within your installation. So something may go wrong just at the motor, and where one phase drops out. It could be right across the whole installation, the whole factory, they may lose one. Or it could even be externally, the network may lose a phase, okay? And then the whole of the factory or wherever this motor is might be down to 2 phases, in which case we want all our motors to stop. Over and under voltage. Okay, over voltage. Insulation failure, over current, temperature rise. So our insulation, we're going to be stressing our insulation a lot more in the over voltage, and it will, and or if the insulation's fine, the extra voltage will cause extra current and temperature rise. Okay, under voltage, load up the motor, we talked about that, and they increase. So they normally come in one unit. It's just a voltage relay, under and over voltage. So there's generally a delay on under voltage. So we set up our parameters, and it may drop down there, but it may take, you may have 10 or 12 seconds, because under voltage, it'll be right for a little while, but it'll be instant on over voltage. It hits the over voltage parameter, the relay will cut out instantly, but under voltage, generally a time delay on it. So it can be a separate unit, or we encompass it. If we buy the right one of these, we can have everything in the one relay. Okay, let's look at over temperature. No, I'm not going to stop it there, and we'll look in the next video.